Hey guys, it's me, Miss Yuli. I'm here with Miss Adams.
Hey guys.
And Lady. Lady, you want to say hi? Speak.
Good girl.
All right, good job. We are going to give you a video today on our 11.01 notes, graphing exponents. You can find this information. Hopefully, you're looking at this worksheet. All right, Lady, go lay down. Hopefully you found this information posted on the website or on our Microsoft Teams page in the assignments tab or on OneNote in your section. And if you have a friend or anybody else kind of not knowing where this information is, hopefully you can help them out or send them the remind code and have them ask us questions. But we're just doing a lesson today, so you can follow along with a printout or on your tablet, and we'll be looking at 11.01. So graphing exponents, looking at our exponential equation, we have our A, H, and K, just like we have been doing this semester when we were graphing functions earlier. So our A value here tells us two things. It tells us if it's negative, that it's a reflection. And it also will tell us if we have a stretch or a compression. It would be a stretch if the A value is bigger than 1, so 2, 3, 4, 5, 6. And if it is a fraction, it is a compression. You also will see the B value. The B is kind of new. All that is our base. So exponential functions, we're raising a base to a power, and we're using the transformations from that as well. So every function will have a base. Just so you guys know, the base will always be there. So if there's only one number, it would have to be the base. It just wouldn't have an A value, or the A value would be 1. The next thing we have is our H value. The H value, remember, we always change the sign. So for H, it will be the opposite. And if it's positive, it moves to the right. And if it's negative, it moves to the left. So the opposite of H, we always change the sign. Positive moves to the right, and negative moves to the left. And then we have our K value. Our K value, if it's positive, it moves up, and if it's negative, it moves down. All right, so those are our transformation rules. Again, those haven't changed. Those are the same transformations that we were doing before, but now we're going to apply those to our exponential functions. So when we graph an exponential function, we want 3 pieces of information. We want to know what the shape looks like, the horizontal asymptote, and the point. So when you look at the shape, there are 4 options. We have growth, and we have decay, and we have no reflection and with a reflection. And so this is what those 3 pieces look like. So first of all, every exponential function has a horizontal asymptote, and we'll talk about that when we get here. But when we have growth, the horizontal asymptote is at the bottom, and then we're going to start close to the asymptote on the left side and grow away from the asymptote on the left side. So I always think growth starts close. Growth starts close. So on the left side, growth will always be close to the asymptote. Close to the asymptote. If I take that and I reflect it, I flip it over, the asymptote will be on the top, and then the curve will be below the asymptote. Again, starting close on the left side and getting further away on the right side. So every time you have growth, we start close to the asymptote. Growth starts close to the asymptote. Decay does the opposite. So decay will start far away from the asymptote. So decay, far away, right? So on the left side with decay, we're starting far away from the asymptote and getting closer. So on the left side, decay starts far away. And if I take that and I reflect it, the asymptote is now on the top, and decay starts far away and gets closer on this side. So those are our 4 pictures. Essentially, you are going to have to figure out if it's growth or decay based on the base, and then what the shape looks like with or without a reflection. To figure out if it's growth, the base always has to be bigger than 1. So the base has to be more than 1. So if the base is 2, 3, 4, 5, 6, that would be growth. For decay, the base is going to be between 0 and 1. So that means that the base is a fraction. Between 0 and 1, 1/2, 1/3, and so on. If the base was 1 and we raise 1 to powers, it doesn't change anything. So we're not going to see a base ever of 1. It's either going to be more than 1 or it's going to be a fraction between 0 and 1. All right, now we're going to talk about the asymptote. So for the horizontal asymptote is y equals k. Y equals k. And the horizontal asymptote is a line that the graph approaches but does not intersect. And this is based off of the information that when you raise an exponent to a power, when you have exponents, the answer can never be negative. When you're dealing with exponents, the answer can never be negative, because when you raise something to a power, you're never going to get a negative answer. Because if we raise something to a negative exponent, it creates a fraction. If we raise something to the 0 power, it's a 1. So you're never going to have an exponent that makes an answer negative. When we do the point, we're going to have an x-coordinate and a y-coordinate. The x-coordinate is going to be from setting the exponent to 0. This is just our h value. Whatever h is going to be used for the x value. So whatever h is going to be our x value. To find the y value, we have to plug it in and solve for y. So we're going to plug that x value in and solve for y. And when we do this, it's going to be important to follow. Please excuse my dear Aunt Sally. Dear Aunt Sally. When you do the order of operations, and it will be the same pretty much every time, but follow that order of operations. And another important piece to this is when you raise a number to the 0 power, that's always going to give you 1 as your answer. And that will happen every single time if you do this correctly. So follow, please excuse my dear Aunt Sally, and when you raise something to the 0 power, it's always going to equal 1. All right, so the next section, we're going to be looking at a picture of the graph, and you guys are going to be filling out some information based on the pictures that you see. So the first question is it growth or is it decay? And that is going to be based off of whether it starts close to the asymptote on the left side or whether it starts far away from the asymptote on the left side. So this graph right here is starting close, so that would be growth. So that's growth because it starts close to the asymptote on the left side. On the left side, it's starting close and it's getting further away. If it is a reflection, that's going to be based on if the curve is above the asymptote or if it's below. If the curve is above the asymptote, then that is not a reflection. If the curve is below the asymptote, like number 2, that is a reflection. And then the horizontal asymptote is y equals our k value, but looking at the graph, the asymptote is right here at y equals -2. That is the k value when we see it in a second. So that would be the k value for the equation. If you look at number 2, is this growth or decay? This on the left side is starting close again, so that is growth. Again, it's a reflection because the curve is below the asymptote, so that is a reflection. And then my asymptote is y equals 1. And that's my k value. For 3 and 4, both of these would be decay because on the left side, they're both starting far away. So decay starts far away. So that's both of these are decay. Number 3, the curve is above the asymptote, so that is not a reflection. But number 4, below, so it's yes, there is a reflection. And then our asymptotes, this one also is y equals -2, and this is y equals 4. So that's just basic information based on the graph that you see. Do you know if it's growth or decay, if it's a reflection or not a reflection, and what is the asymptote looking at the picture of the graph? The next part, you will actually be drawing the graph yourself and listing the characteristics. So we're going to be drawing the graph and listing the characteristics. Remember, every graph has to have the horizontal asymptote. It has to have 1 point. And you have to correctly draw the shape. So let's just go ahead and list the information. Looking at the equation, the first thing I'm going to list is my A value is 3. My A value is 3 for transformations. That means that the graph has a stretch by 3. The H value here is +2. So the H is the opposite of that, making it -2. It shifts the graph to the left 2. Remember, this is always the opposite. We're only going to change that sign one time, so don't change it multiple times. And then our K is -6, so that shifts down 6. K also makes our horizontal asymptote. So if K is -6, that means my horizontal asymptote is y equals -6. So that is from the K value. And I can go ahead and put that on my graph. So K is -6. Down here. So we have my horizontal asymptote on my graph. The next thing I need to do is find my point. I am just going to find 1 point on the graph. If you want to use your calculator, seeing as you are at home and not in class, you can use your calculator and use the table function in your calculator to find multiple points. But I do want you to be able to show 1 point algebraically. How do you find that 1 point? And this is how you do it. So when I'm finding a point, the x value of the point, the easiest one to find, is always using our h value. And I'm using the h value that I already changed the sign. So I'm not changing the sign and doing the opposite again. It's just whatever the opposite was from the equation. The opposite from the equation. And I'm going to go ahead and plug that value in for x. So I'm replacing that x with that -2. So 3 times 2, -2 plus 2, minus 6. So I'm plugging in my x value to find what the y value is going to be. This is where you're going to use, please excuse my dear Aunt Sally. So the first step is to do the exponent, well, parentheses. So I'm going to do my parentheses first. In parentheses, I can add -2 plus 2. So 3 times 2 raised to the 0 power minus 6. So please, parentheses, next is exponents. 2 to the 0 power is what? Is 1. So 3 times 1 minus 6. Then I'm going to multiply 3 times 1, which is 3. And 3 minus 6 is -3. So my point is -2, -3. So I've now found my point, -2, -3. And I can list that on my curve as well. This point is a little bit further away from the asymptote than we were seeing here. And that's because it is stretched out. So the stretch of 3 takes it and it stretches the curve further away. All right, now let's talk about the base. The base of this equation is 2. So the base is 2, which is more than 1. So that means that this is growth. Because the base is more than 1, it's growth. If it was a fraction, then it would be decay. And if it's growth, that helps us determine the shape. In this case, the shape is going to start close. So growth starts close to the asymptote on the left side, and it gets further away on the right side. And again, it is a little bit further away from the asymptote than we were seeing over here, and that's because of the stretch. But just start close on the left side and get further away from the asymptote on the right side. All right, domain and range. Looking at this picture, the domain, if I'm looking to the left, that arrow is going all the way to negative infinity. And on the right, this arrow, it's going very steep, but it is going to positive infinity. This will be the same for all exponential functions. So this is the same for exponential functions. When we do log functions, it will be different. So it's not negative infinity to positive infinity every single time, but for exponential functions, it will be negative infinity to positive infinity. The range is going to have the horizontal asymptote in it. So this horizontal asymptote is going to block that curve from going to negative infinity. So it is not going to go from negative infinity to positive infinity because there's a block in the way. So this graph is going to go from -6 to positive infinity. So it starts, the lowest it could ever get is -6, and it goes up to infinity. And the reason I used a parentheses is because you're not allowed to touch that asymptote. It's going to get closer to it, but it's not going to ever cross or touch the asymptote. So I would list that with a parentheses. And then the last thing that we have to list is our increasing or decreasing. If I am walking on this curve and I'm starting on the left side and I go for a walk, I would be going up really steep. So this graph is increasing. The graph is increasing. All right, so that is one full question that we've done together. So let's turn the page, go to the next page, and practice another question. So on the next page, we're going to look at number 2. And feel free to pause the video and try it on your own if you guys want to go try it and then check your work. That would be awesome, or you can just follow along. So our A value for number 2 is a -1. Remember, if you only see one number, this has to be the base. The 1/2 is the base. You are not allowed to have an exponential function without a base, so that would have to be the base. And the 1 would be in front of it as an imaginary 1. So the base is 1/2. Our H value, changing the sign, is a +2. And our K value is a +8. If I do my transformations, this is a reflection. It's going to the right 2. And it goes up 8. And that up 8 also is my horizontal asymptote at +8. So up 8 is my horizontal asymptote, way up here. All right, the next thing I need to do is find my point. When I find my point, my X value is my H value, the opposite from the equation. So it will be a +2. And I'm always using that H value because that's going to make the exponent 0, which actually makes the point way easier to find. So when I plug a +2 in, 2 + 2 is my exponent, +8. And every single time, if you choose the right X value, your exponent is always going to end up being 0, which anything to the 0 power, fraction, a really big number, a variable, is always going to be a 1. So that just makes it really a lot more simple to solve. So 1/2 to the 0 power is 1. So negative times 1 plus 8. Negative times 1 is -1. and then I can add 8. Negative 1 plus 8, which is 7. So my point is at 2, 7. So over 2, up 7, and right there. And that is a lot closer to the asymptote this time because there is no stretch here. So it's a lot closer to the asymptote. You'll also notice that the point is below the asymptote. The only time the point will ever be below the asymptote is if you have a reflection, which we do here. So since it's reflected, the point is below the asymptote. If there's no reflection, the point should always be above the asymptote. All right, so let's talk about the base. In this case, the base is 1/2, which tells us that this graph is decay. It also tells us we're going to start away. So when I draw my shape, I'm going to start on the left side far away and get closer to the asymptote, but never cross it. So I start far away and then I get closer to the asymptote because it was decay. For exponential functions, my domain is negative infinity to positive infinity. There's nothing stopping it going from left or right. But the range goes, in this case, from negative infinity, because that's where the arrow is pointing, up to 8. With a parentheses because you're not ever going to touch that asymptote. You can't touch the asymptote. And that is from my k value and for my asymptote. All of them are the same. All right, and then increasing or decreasing, if I am walking on this curve, I am going up the curve, so this is increasing. You're always going from left to right like you're reading a book. All right, again, feel free to pause if you want to try number 3 before I go over it, but we will go through number 3 next. So on number 3, my a value is 2, my h value is negative 1, and my k value is 2. So my transformations are a stretch of 2. We have negative 1, so that graph goes left 1 and up 2. Up 2 is also going to be my horizontal asymptote, so y equals 2 is my horizontal asymptote. Up here at 2, we have our asymptote. And then we can find our point. To find the point, I'm going to use my h value of negative 1 and plug that negative 1 in to see what my y value is going to be. So when I plug negative 1 in, I get 2 times 3 raised to the negative 1 plus 1 plus 2. And I'm following, please excuse my dear Aunt Sally, so I do the parentheses first. Negative 1 plus 1 is 0. 2 times 3 raised to the 0 power plus 2. 3 to the 0 power is 1. 2 times 1 plus 2. 2 times 1 is 2. And 2 plus 2 is 4. So my point is negative 1, 4. And that is above the asymptote, which makes sense because this is not a reflection. Remember, the only time your point is below the asymptote is when there's a reflection. So you can use that to check yourself. Does that point make sense with this problem, being that there's no reflection? In this case, it does. But if you got a point that was below it, then maybe you think, I might have done that math wrong. All right, so looking at our base is 3, and 3 is more than 1, so that's growth. So that is growth. And when we draw growth, growth starts close. So starting close to the asymptote on that side and growing away from the asymptote. Starting close and growing away from the asymptote. Domain is still from negative infinity to positive infinity. There's nothing stopping it on either side. But the range starts here at 2 and goes up to infinity. So starting at the asymptote and then going up to infinity. And then if I was walking on the curve, then I would be increasing going up. So that's increasing. All right, so that was question number 3. Question number 4. We have an A value of 3. So that's a stretch by 3. My H value is -1. Well, actually, it's the opposite of -1, which is +1, which shifts it to the right 1. And then K is -3, shifting this down 3. That also tells me my horizontal asymptote is -3. And I can list it and draw it on my graph. So here at -3, I have my asymptote. All right, now I'm going to find my point. To find the point, I'm using my H value. The H value is at 1, and I'm going to plug that in. So 3 times 1/2 raised to the 1 minus 1 minus 3. And I'm following, please excuse my dear Aunt Sally, so I'm trying to figure out what this is. 1 minus 1 is 0. 3 times 1/2 to the 0 power minus 3. 1/2 to the 0 power, anything to the 0 power is 1 minus 3. 3 times 1 is 3. And 3 minus 3 is 0. My point is over 1 up 0. And this does make sense with my problem because there is no reflection, so my point should be above the asymptote. And it's more above the asymptote than just one box because of the stretch. All right, looking at my B value, my base is 1/2. So that tells me that this is decay. And decay starts far away. So on the left side, starting far away from the asymptote and then getting closer on the right side. So decay starts far away on the left and gets closer on the right. Domain is -infinity to +infinity, and then the range goes from -3 up to infinity. Can't cross the asymptote, so it starts here at the asymptote and then goes up to infinity. This graph, if I'm following it walking on the curve, I would be going down, so it's decreasing. And this is different than if it's growth or decay. So just because it's decay doesn't mean you'll be decreasing, and just because it's growth doesn't mean that you'll be increasing. So just follow the curve, not just whether it's growth or decay. So that, in this case, it matches up, but sometimes it does not. So just know that. All right, this is your 11.01 notes. Hopefully you are watching this video before the live chat. We will be going over this and answering any questions on the live chat on the 24th. So feel free to join us on the live chat to ask questions, or you can text us on Remind. Just let us know if you need help with anything. We're always available on Remind or through email. So just keep us posted. Thanks.
Bye, guys.